Good morning. Today what we're going to do is finish off the last section of Chapter 9, Pre-Calc 30, taking a look at graphs and rational equations, solving both algebraically and graphically different rational equations. So the first example that we are going to take a look at is asking us to find the roots of this rational equation algebraically, and again what makes it a rational equation is that we have these fractions, we've got variable expressions in the denominator. That's what we're looking at. So when you take a look at solving this algebraically, this is actually something that was done in Pre-Calc 20. One of the concerns, and I've already got to fix that. One of the concerns when solving algebraically or solving rational equations is that we have non-permissible values. So before I go on any further, one of the first things that I want to do is find the non-permissible values, because those denominators that can't equal 0 are tied to the lowest common denominator that we are going to need to help us solve this equation. So first things first, our non-permissible value, our denominator of x, can't equal 0. And how that ties to our lowest common denominator, that is the denominator, and so our lowest common denominator is simply x. What we're going to do in the case of solving rational equations is we are going to multiply to get rid of that denominator of x by multiplying every term in our equation by the lowest common denominator. So what we've done in the past is multiply every term. And remember, our terms are separated by those adding, subtracting, equal signs, with the purpose that we are going to be canceling that denominator. And so in the end, we have 14 take away x squared plus 5x is equal to 0. And so what we're left with is an equation that we need to solve. And looking at this, we have a very traditional looking quadratic equation, which we've solved before. I'm going to move all my terms to the other side just for simply making that x squared positive. Moving the 5x over is going to make it negative, and the 14 is going to also be negative. To solve this quadratic equation, I'm going to factor it. Two numbers that multiply to negative 14 that add up to negative 5 are going to be negative 7 and positive 2. And when we split those factors, x minus 7 equals 0, x plus 2 equals 0. So we get a positive 7 and a negative 2. And so we have solved algebraically for this rational equation. We've got two solutions, 7 and negative 2. We always need to go back, though, before we can officially say we're finished, and compare to our non-permissible values. And x can't be 0. That wasn't a conflict with one of our solutions, so it should all be fine. So in part B of this question, they're now asking us to find the x-intercepts of the graph of the following corresponding equation. And if you take a look at the only difference between the two equations is that from the equation we solved algebraically to the equation they're asking us to graph, the y and the 0 are replacing each other. And so when we find the x-intercepts of any function, and we let y equal 0 in the equation, that's how we solve for x, which is essentially what we did here. So when you go to determine the x-intercepts of the graph, you really are finding the solutions. This is the solution or the solutions to the rational equation. So if you were to take a minute and look at this equation, y equals 14 divided by x minus x plus 5. And if we're going to go to a nice window, you're going to see, yes, that we have one solution at -2 and another x-intercept at 1, 2, 3, 4, 5, 6, 7. Yep. So those two things are going to correspond, that when you are finding the x-intercepts of a graph, you're finding the solution. And that's what part C is asking us to do. So in section 9.3, your expectations are to be able to solve algebraically and to be able to solve graphically. So solving graphically using the graphing calculator, of course, the biggest concern is that you need to be able to enter equation properly into the calculator so that there's no miscommunication. Please make sure that when you're putting a numerator, it's in brackets, divided by, and again, brackets around your denominator to make sure that you are getting the correct equation entered and the correct solutions. I'm going to focus on solving them algebraically. So with this particular equation, one of the most important things that we're going to do with all of these rational equations, and this is kind of my official steps to solve. The first thing that you're going to do is factor your denominators to find your non-permissible values and your lowest common denominator. That is priority. So when I look at this denominator of 2, of course it's fine. We're focusing on the denominator, so I'm leaving the numerator alone. The denominator, there's a common factor of 2. And my pen's dying on me. 2x plus 5. So I found that my lowest common denominator, well, I guess maybe I should start with my non-permissible values, because there's two things to take into consideration. Both of these are focusing on the denominator. When we talk about a non-permissible value, we're focusing on things that involve a variable. So the fact that we have 2x plus 5 as a factor in the denominator, that cannot equal 0. And so when you treat this like a little equation and get x by itself, move the 5 over, divide by 2, we have a non-permissible value of -5/2. But when we talk about our lowest common denominator, we need to take into account all of our denominators. The fact that we have a factor of 2 in both of these denominators means that we have 2 part of our lowest common denominator, as well as that 2x plus 5. So recall what we were doing with that lowest common denominator is we are going to multiply every term by the lowest common denominator. And remember, the purpose behind this is to cancel all denominators. That's what our goal is. So if I were to multiply by 2 and 2x plus 5, by 2, 2x plus 5, and by 2 and a 2x plus 5, we would see this entire denominator canceled. The 2 would cancel with the 2, and that would mean it looks like for the first term, in front of the subtracting sign, we'd have 2 times 2, which is 4, and then that 2x plus 5. We have a 3x and a 2x plus 5, and we have that trinomial. Oh, I guess it's not being multiplied to anything, so I didn't need the brackets. But what we end up having is an equation now with no denominators. So what we're going to do next is we're going to expand. We're going to simplify to collect like terms, and solve for x. So in this particular case, when we start to clean this equation up, multiplying the 4 in, multiplying the 3x in, and our equation on the other side, collecting all my like terms, I'm just gonna simplify this side. It looks like I have a negative 6x squared. I have negative 7x plus 20. And when I start to move all my terms over, when I add an x squared to both sides, when I subtract 4x, and when I subtract 1, I get that 5x squared minus 11x plus 19. So I'm back to a quadratic equation. And this is one thing that we're going to have to be aware of, is sometimes these equations, once we get them simplified, getting ready to solve for x, sometimes they may be linear, sometimes they may be quadratic. So we have to be prepared for whatever kind of equation that we have here. And so when I take a look at this equation, usually we can factor to solve a quadratic equation like I did with the last one, but not all of them are factorable. In this case, we'd be looking for two numbers that multiply to negative 95, that add up to negative 11, and that is not factorable. So in this particular case, because we can't factor to solve, we may need to use the quadratic formula. And in this particular case, with A being negative 5, B being negative 11, and C equaling positive 19, we're going to need to use the quadratic formula. Over to A. So that means we will have the negative of negative 11 plus or minus our negative 11 squared minus 4 times A times C all over 2 times our negative 5. And so what we end up with here is positive 11 plus or minus, and when I do all the work inside of the square root, I have, oopsies, my negative 11 squared is 121, and I'm going to have two negatives, so it's going to end up being plus 4 times 5 times 19. So inside my square root, I end up with 501 all over negative 10. And when we solve for each of these solutions, 11 plus the square root of 501 divided by that negative 10, one solution we get is negative 3.34, or the 11 minus the square root of 501 divided by the negative 10, and we get a positive 1.14. We end up with two solutions, and in this particular case, there's again no conflict with our non-permissible values, and so therefore I believe we have two good solutions. So the steps that we need to go through to double check and make sure that we have our non-permissible value, our lowest common denominator. We follow these steps very similar to what we've done in the past. Okay, and if you were to take some time to graph it, with this particular equation, what we have is work on both sides. So when we go to put an equation like that into the calculator, we have to do it in one of two ways. And I'm going to show you with the next example what we would do if we were to solve it graphically. This one I'm going to focus on solving it graphically. When we are solving an equation graphically, we do have two choices. The very first example that I did solving it graphically, we could put the equation as a single equation. Enter equation as a single equation. And if that's the case, then what you are looking for is you are going to find the x-intercepts. So in this particular example, if we were to solve it graphically as a single equation, we would just need to move everything onto one side. And I believe that the easiest way to do that would be to move this entire term on the other side. This fraction is positive, so when I move it to the other side, I would just subtract that whole fraction, something like that. So when I go to enter the equation into the graphing calculator, I need to make sure again that when I put the numerators into the calculator in brackets, dividing by the bottom one. The other option, and it really depends on what you prefer, you can enter the equation as two equations. Enter equation as two equations. And then what we are going to do is find the points of intersection. Find points of intersection. So what we would do is take one side of the equation, the x plus 3 over 2x minus 6 as one equation. The second equation on the other side, 2x minus x over 3 minus x. And we would again enter two equations and ask the calculator for the point of intersection. And your solution is the x values. That's what we are focusing on as your solution for solving it graphically. So with most of these questions, we need to be able to solve both algebraically and graphically. I'm not going to go through the last word problem with you. What we will do is focus on page 465. 3, 6, 10, and 11 are the questions to do for section 9.3. That's all for today.